In this question, we're asked to identify the red one as a Bronsted-Lowry acid or a Bronsted-Lowry base, or neither, although in the several examples I looked at, I didn't see anything of like a salt dissolving in water, which was neither. That's not to say there aren't any, but everything I saw was an acid or a base. So my printer isn't color, so instead of red, I underlined the one that is red, because it matters, right? Because one's going to be the acid and one's going to be the base. So you need to make sure you're identifying the correct one. So just to make sure we understand the difference between a Bronsted-Lowry acid and a Bronsted-Lowry base. A Bronsted-Lowry acid is something that donates a proton, NH+. A Bronsted-Lowry base is something that accepts a proton, NH+. So what you need to determine in each case is whether the thing accepted a proton or whether it donated a proton. And when you do that, you essentially need to see what it becomes. So in this case, H2O. Does it become I minus or does it become H3O plus? Well, H2O must become H3O plus, right? Because it's much closer to this. It doesn't have an iodine in it, all right? So this has to become this. So if water becomes H3O plus, does it gain a proton or does it lose a proton? Well, it had two H's here, and it has three H's here and a plus charge. So here it's neutral, here it's plus. So it gained an H and a plus charge. It gained an H plus. If something gains a proton, it's a base. Remember, a Bronsted-Lowry base is a proton acceptor. Let's look at the next case. We have H3O plus. Does it become HI? No, it doesn't have an iodine in it. Does it become H2O? Yeah, it becomes H2O. We only have two choices, so it becomes H2O. We have three H's, an O, and a plus charge. Here we have two H's, an O, and no plus charge. So this lost an H plus. It lost one H and the plus charge. So if it lost an H plus, it donated that H plus to this. So therefore, it acted as an acid. And if we look at the I minus for a second, it gains an H and it goes from a minus charge to neutral because it goes from I minus to HI. So it gains an H and a plus charge, which cancels out that negative charge and becomes no charge. Let's look at another case. Let's look at I minus plus H3O plus. This is actually the same reaction, except we're asked about I minus. Well, if H3O plus acted as an acid, I minus better have acted as a base. But let's make sure. I minus becomes HI. It gained an H and it gained a plus charge. Again, minus goes from minus to neutral. So therefore, it gained an H plus, therefore it acted as a base. To review, Bronsted-Lowry bases are proton acceptors, Bronsted-Lowry acids are proton donors, with the proton being H plus. Here we have HI plus water. This is actually the same as the top reaction, except we're asked about HI in this case. In this case, HI becomes I minus. So identify which product it is. It's the one with the iodine in it. So it lost an H plus. It went from neutral to now negatively charged. If something loses or donates an H plus, it donated that H plus to water, then it's going to act as an acid. So this is how we identify Bronsted-Lowry acids and bases.